Okay, this is going to be the fourth and last video for the image enhancements and pan sharpening activity, and what I'm going to do is just finish up the lab, right? So we've looked at pan sharpening, we've looked at image enhancements, we've looked at contrast, stretching, gamma, which is for color balance. We've looked at how to symbolize these rasters, right? And I think what I want to do with this video is try to bring the story through, right? Because we downloaded imagery for the same path and row for 4 different dates, showing the Kenora 51 fire, which happens, July, August of 2021. So what I want to do here next is go through the rest of the lab and make it all make sense. I really hope I can do that. And you can see that I've got my Word document up, and it's not complete, right? There's some missing stuff from a few of the questions. I'm going to go through it with anybody who's watching, and we'll get it all finished up, right? So where I had left off was in question number 7, where we did the pan sharpening, and all of the data is still in the project, right? I have my open project. I have recently saved it, and we were swiping across, showing the pan sharpened areas, right? And all of the data is there. That's Red Lake, and you can look at all kinds of really neat things. We looked at this lake over here, which is really shallow, and you can see the difference between pan sharpened and non-pan sharpened true color data. So we've got lots of interesting things happening in the contents pane, right? I've got a pan sharpened image, I've got a non-pan sharpened true color image here, right? Those were both created using the composite bands tool and the pan sharpening raster function, but we still have all of these other pieces of data. Here is a true color, and the trick is that you got to check the dates out, right? Because this is also a multi-temporal analysis where we've got June 13th, 2020, and then we've got July 2nd, 2021 when the fire's happening, and July 18th, 2021 when the fire's happening, and then one from October the 6th of 2021 where the fire's out, and you get to see the final burn scar. In this lab, right, you're required to work with the imagery, enhance the imagery, just working with a single path and row. We're not mosaicing anything, we're not doing any of that, which is totally possible, right? There's quite a bit more area around this. And I guess where I want to go with this video is to just try to tie up all of the loose ends and try to give everybody an understanding of why we were doing this, right? In the process of enhancing and modifying the gamma and just using the composite bands tool for multiple dates across the same path row, all of that, these are all very common tasks. These are all very basic beginner level tasks for working with Landsat imagery in the ArcGIS Pro interface. And really, I really enjoy this lab because, it doesn't have to be for this particular area. You could find Landsat data for all kinds of regions on the planet, and the limiters are going to be whether there's cloud or not. So that's kind of where I'm going to go, and let's just get right into it. I'm going to turn off my swipe. That's pretty important. So I'm just going to switch over to just the regular selection tool. Nothing really to select. I'm going to turn on all of my 7-band images. I'm going to turn off my camera. You should still be able to hear me, I hope. I'm going to turn on all my images to try to, set it up as kind of like a story. And these other images, I'm going to remove them because we don't need them. Those are the straight 432 that we used in the pan sharpening process. Let's just look at the raw 7-band imagery. Some of the enhancements from previous portions of this activity are probably still set. This image right here, the July 2nd image, it's in a 765 right now. I can check that. Looks like it's a 765. Yep, it is. Right, so I can change that back over to a 432, but the reason why it's in a 765 is because we want to be able to see the fire. And if it was in a 432, all of the ash and smoke would be obscuring, and we wouldn't be able to see through it, right? The shortwave infrared and near infrared bands allow you to see through ash and smoke, not through cloud, but that's how that works. So I'm going to just keep that one there, and you can see the before versus, oh, here's the fire, right? It's happening. And in this one, same thing, we've got a 432, no, we've got a 765. Let's get our symbology pane up. Right click to open up the symbology pane, and I can see that I'm using some interesting stretch types and stuff. Let's just go back to a percent clip, and let's go to bands 4, 3, and 2, and you'll notice that the imagery is not the greatest for this date, the July 18th date. Not only is the 432 bands combination really dark, also there's a lot of cloud obscuring it, right? So that doesn't mean that it's a useless image. In fact, it's a very, very useful image if you view it in a 765 band combination, right? Because you'll be able to see through all of the cloud, or the ash and the plume, but not the clouds. And what I mean by that is all of the ash plumes that are here for this very active fire, July 18th of 2021, right? If I want those all to go away, I just have to switch over to a different band combination, right? A 765. It makes it very quick to switch between different band combinations when you have a composite that has all of the first 7 bands in it. Now let's try to make this look a little bit nicer. This is just a quick review. I usually go with a 0.1 on the top, and maybe a 0.5 on the bottom, and I turn down the blue, and I turn down the green to be able to view that. Now let's also look at the appearance on the ribbon. Let's see what's happening here. We've got 10% contrast, we have 0 for brightness, that's fine. These flames are really showing up as being ultra bright. Same with the clouds, and that's what the issue is here. Color balancing can be difficult, and image enhancements can be a little bit tricky when you have cloud in your image, because all of those clouds that's your my scattering that's causing all of these super bright white values, and it throws off the histogram. So you kind of have to play around with it to see what you can do. A percent clip, maybe if I want to make this a little bit brighter, maybe I can increase the clip on the top. See what that did? It brightened up those values, and I'm able to see the scar a little bit clearer. And I can even bring it a little bit lower on the bottom. There we go. So when you're working with a percent clip as your enhancement contrast stretch, right, you can work with these, and as long as you understand what's being done, it's fantastic, right? So this is a massive fire. I mean, look at what's happening here. We can measure the distance or the swath of this burning front. We just have to get to the map tab and grab our measurement tool. How wide is this? We're looking at 20 kilometers wide just on that front. And it's going on all the way up here. There's some really intense things. And there's a settlement close to here as well. This is Red Lake. I can prove that it's Red Lake by turning on the topographic map in the background. It'll pop up in a second. And you can see Red Lake is right here. That city, there's, I don't know, maybe 4,000 people that typically live there. They had to be evacuated for this particular fire. I turn on the fire again, and you're like, well, why would they have to be evacuated? Well, look, this front right here is less than 40 kilometers away from the city, and you're like, well, that's a far distance. But if you look at, the size of the fire, the danger is extreme, right? So get everybody out of there, right? Really, really interesting, but also scary stuff. This fire was really intense, really large, and if you want to look at the final burn scar, that would be right here. You can see I've got it in a 752 combination, which really enhances things and makes the fire scars pop, really, and be very, very different compared to anything that still is vegetated, right? And this area burns every year. There's this part of northwestern Ontario is, you get a lot of fires in this area. I'm going to turn off the imagery and show you what I mean by that. I've got an Ontario fire disturbance layer that's a shapefile, and you can see that, in the last greater than 50 years, look at how many fires have been in this area. Like, it burns all the time. Every year you're going to get fires up in this area, and the trick is, okay, well, what kind of suppression is going to be involved? Are these fires going to be, are they going to be suppressed? Absolutely, they're going to be suppressed if they're within a distance to a larger community, or even any community at all. So there's the evacuation side of it and the fire suppression side of it. And that is that's key to understanding how, we expend our resources in Ontario for forest fires. And there were some fires in different areas more recently. There was one down here that was pretty intense, and it's a more recent fire. If I click on it, it should tell me what the year was. 2018. That's the Perry Sound fire. This fire, being so close to Highway 69 and being close to a few settlements and some provincial parks, and it was pretty intense and scary, right? So Bon Air is right there. Pickerel River, Key River, right? These are all settlements that were in danger, and there was some evacuation that had to go on there. So you could apply the same analysis that we applied to this area for any of the forest fires that have been happening over the last, if you want to use LandSat8, you can only really go back to 2014, but you've got other Landsat sensors like LandSat7, LandSat5, and even previous to that you've got others, right? So it's kind of neat to be able to have 40 years worth of Landsat data to draw from, and be able to look at some of the fire history in Ontario. It's fascinating, but it's also pretty scary to see, the amount of damage that occurs in the forest, and that's it. So I'm going to turn these off, and I'm also going to turn this off. We've got a blank map. There's not really much going on at all. And in the Word document, let's go and see where we had left off. I'm going to go all the way to the start, and question number 1. Right, the imagery scenes used for this assignment were acquired from using the Glovis interface. There are other download interfaces. There's one called Earth Explorer, which is great as well. I prefer Glovis just because that's the one I've been using for years. What do we have to do here? It says you need to input the file name, the size, the path, the row, and the acquisition date for all of the images that were used in the exercise. Now, you may have 3, you may have 4. If you have 4, you're going to have to add another row, no big deal. And let's go and look at what data is missing. So this one right here, we've got the date. The acquisition date is June the 13th. Great. the beauty of all 4 of these images is that they're all the same path and row, so that's pretty easy. We just put those in. Oops. And actually they're all the same size, approximately. So that's pretty easy as well. The acquisition dates are going to be different. And the file names are obviously going to be different as well. So let's go and figure out what's happening there. I don't even know if I have. Oh, I do. Perfect. Let's go by type. Let's go find all of these. These right here, I've got 4 of them. Those are the original downloads, right? When you download from Glovis, you get an archive compressed data set. You know, all of these TIFFs and everything that's in this folder, they all started from here, and you can see here's the one that we've already put in. Let's grab the file name from here and put it in the Word document, and just go back and forth and input the stuff that we need. So there's that one, and we'll go back to grab this one. And I'm not changing these. Don't change the file name in File Explorer. You don't want to do that. What you want to make sure you keep doing is just grabbing the names just to put them in. And it's a good practice because it helps you to familiarize yourself with the data that is downloaded. It helps you to understand what you need to do to the data. It helps you see the sizes of the files, right? And understanding path and row and acquisition date is also a huge part of this as well. So I have one more to put in, and each of these, once the file names are inputted, I don't need to look too far to find the acquisition dates. It's important to realize that, okay, this is the acquisition date right there, 2020-06-13, right? So that same set of numbers right there is the acquisition date. We've got a 2021, '07-02, and then we've got the others, which are the same, but instead of 02, this one is 18, and this one, the last one, is from October 6th, right? They're all the same path and row. You can see it, 29-25, 29-25, right? So that is a completed number 1. Number 2, the first bands, or the first 7 bands of each of the Landsat scenes above were added, and what geoprocessing tool was used to create color composites for Landsat 8 imagery. Describe how the tool works when combining more than 3 bands together, right? So understand that we use the composite bands tool. It's a geoprocessing tool in ArcGIS Pro used to create multi-band imagery. And I would say TIFFs, but it doesn't have to be a TIFF. It could be an IMG. It could be, you know, other forms, JPEG 2000, whatever. And I'm not going to be typing the answer in here for each of you. You've got to come up with your own description. It's worth 2 marks, so I'm looking for a minimum of 2 sentences there. Question number 3, true color composites were created together in class, right? And we played around with the different enhancements on the left, right? We've got the percent clip, and on the right, we've got a standard deviations. Those enhancements were done with just a true color band combination for this image is the pre-fire image. So we did that in the first video, so let's keep moving forward. And then in number 4, you're required to create some band combinations, right? So we need a full image scene and then a 1:1 raster resolution. Just as a review, for Landsat 8 imagery, a full image scene is at a scale of about 1 to 1,000,000. Okay, and if you're zooming into 1:1 raster resolution, what that means is that if you've got 30-meter pixels, the closest you should be able to zoom in on a 30-meter pixel in the ArcGIS Pro interface is at about 1 to 100,000. So 1 to 1 million on the left, 1 to 100,000 on the right, and modifying the band combinations so that we can see differences in reflectance values across different band combinations or wavelength ranges, right? So there's your 543. Your 752 should look like this, where you've got a heavy reflectance, very bright green values, and that's because the near infrared band is band number 5, so it's in the green position, meaning that all vegetation should be reflecting very high in the green color range. Anything that's not vegetated is going to be reflecting differently. In the shortwave infrared, you get very high reflectance values in the red, right? So in the red and the, well, not, and so on. So that's your band combination. That's a 752 right there. And there were 3 more that were required. You've got a 765. We need same thing, full image scene and a 1 to 1. Then we need a 654 and we need a 562. So yeah, I'll go and do these, but I'm not going to be explaining myself a ton. All I'm going to do is just grab what I need and put them in, and you'll be able to see what it should look like. That'll help you to get full marks. All right, so let's go and do that. My first one is a 765, so that's no problem. Done that before, and I'll use this first image, 765. Right now I've got this pop-up window. I don't want it, I want my symbology tab, so follow my mouse, you can see that the symbology is right here, 765, change up the band combination. This is what a 765 should look like. It should be heavy on the blue with some orange if you have forest fire scars. I'm going to modify my coloring here a little bit, 1.1. Maybe I'll brighten this up a little bit on this end. Oh no, I'll leave that there. Maybe I'll brighten it up a little bit more on this end with like a 2% clip on the high end. That brightens it up. Now my blue, I'm probably going to bring it down. My green, actually I like that. Fine with that. Alright, so now full image scene. Right, we've got it right there. Maybe what I'll do is drag this window here and just type in 1 to 1 million. Grab a screenshot of this. Word document right here. I'm not even going to bother cropping it yet. I can do all my cropping afterwards. Right. Let's go back to ArcGIS Pro, and next I need to find something cool to zoom into at a scale of 1 to 100,000. I'm going to zoom into this area right here because it looks interesting to me, and type in 100,000 right there, and same thing, drag it out so I can see the whole thing, position it the way I like it, and grab another screenshot, go to the Word document, and just paste it in. I can go and format these after. Now my 654 is next. Let's go back and work with a 654. Instead of 765, we're going to go 6, 5, and 4. And zoom out to 1 to 1 million so we can see the whole thing. Now in this band combination, same thing. We've got the near infrared band is in the green position, so anything that's vegetated is going to look very green. And then we've got the red band in the blue position, and we've got the shortwave infrared band in the red position. No problem. Let's start by just evening out the gamma. I'm going to put the gamma at 1 all the way across. See how quickly I was able to do it by using the ribbon interface? A little bit easier to do it that way. And maybe I can just check my percent clip. That's not bad. If I bring when just looking at this raw, I'm saying I need less green. And maybe I'll bring the blue up a little bit. Just playing around with gamma. And the red, one on that one. And maybe I'll increase the, what happens if I go really, really high with my cut or my percent clip? That's a little bit too much, I would say. Let's only take about 2% off the top. This is what you should have. This is a nice looking enhancement. Maybe I'll increase my low end, the cut on my low end. That helps to kind of take the haze out of things, and I like it. So I'm at a 1:1 million scale. Same thing, let's just get the whole thing inside of one screen, print it out, and go into my Word document and paste that in. Go back and find something interesting. What can I find that's interesting in a scale of 1 to 100,000? Well, you know, we had looked at this city at 1 to 100,000, but I would say let's go find something else. There's got to be something else that's interesting. On a scale of 1 to 100,000, you can just sort of move around the image and find something, right? We looked at this burn scar already in one of our screenshots, so maybe that's not what we want. There's some interesting stuff happening over here. A lot of the swamps, some of the swamps are giving you this kind of minty green color. A lot of the rock is showing up as like a really kind of Pink Panther pink, Pepto-Bismol pink, whatever. That's kind of neat. Let's look over here. Anything that really stands out? We got some interesting colors happening here. Got a real variety of color happening, and that's what we're after. Right? Anything that's not vegetated is going to show up as a bright, bright pink. So let's grab this one, put it in. I'm happy with that. Really cool to look at. I absolutely love playing around with imagery. There's so many cool things you can find. So we'll put that in. Now the last band combination is a 562. I believe. Is there another one? No, just a 562. So that's no big deal, right? Same thing. We can zoom out all the way, and we can go and modify our bands to be 5, 6, and 2. What does that do? That really, what that does is it puts the near infrared band in the red position, so everything looks super red. And we've got a 5, a 6, and a 2. So 5 and 6 are both very, there's a lot of information there to work with. But what I want to do is I'm going to leave the clip the same, but as far as the percent clip, I'm going to even out my gamma and just have a look at it. And you know what? We're going to leave the blue at 1, but we're going to modify the gamma on the red. Let's bring it down, and the green. Let's see what happens. What does that do? It really does help us to see anything that's vegetated, and it also helps to look at different, it makes rock really stand out. So there's some interesting things to look at there. Let's get our full scene at 1 to 1 million. When I'm typing in the scale, I never put the 1 colon part of it. I just type in the number that I want and press enter, and it pops me out. So there's my full scene. Print the screen, go to the Word document, pop it in. There it is. Now my next one is a 1 to 100,000, and I've got to find something interesting. So let's go over here. That's pretty cool looking. So now all that's left to do is just crop all of these. So no big deal, right? I'm going to crop them so we can see the full image. I'm going to try to do this as quickly as I can. because this is probably the most boring part of the video. And in fact, you know what? I'm going to pause it, and you'll come back and everything will be cropped. Okay, so you know, you didn't want to watch me have to crop all these images and get them formatted properly for Microsoft Word, but basically, you know, now you're set up and you can see that the different band combinations required for question number 4. There was a fair amount of work there because, you know, you had to go back and switch out the band combination and view the whole scene and then find something interesting at 1:1 resolution and so on. So there, again, the activity is all about just helping to build confidence with modifying band combinations, modifying enhancements, and working with multiple images or multiple bands within a single image. And so, you know, as far as the Word document goes, question number 4, here's your 543 at the top, and then we go to a 752. You can see that there's quite a bit of a difference between the different levels that you get from different bands, and it's all about looking for features and accentuating features, right? So in a 543, you want to try to accentuate vegetation, and you want to accentuate it in a way where maybe you can see the difference between hardwoods and softwoods and so on. And in 752, then you got to kind of think about, well, what am I looking for here? In a 752, this is a great band combination for showing damage or disturbed areas, or especially fire areas. I love that one because you've got like this bright pinky red versus you know, this kind of limeish green color for vegetated areas. It's a really good one to use. As far as atmospheric penetration goes, being able to see through haze in the atmosphere, but also a lot of, you know, pollution, ash, smoke plumes, things like that from forest fires. Your 765 is a great one to use. And then, you know, you're required to do a 654, which could be used for, you know, finding urban areas, non-vegetated areas, and even to some extent agricultural areas. The 562, I've always thought about it as being one where it helps to accentuate different rock types, different soil types. And of course, it still is yielding a pretty good difference between vegetated land, non-vegetated land, but also organic soil versus mineral soil. That's a good one, and soil moisture as well. 652, I added this just because I was just messing around, and I was like, you know what, I want to add another one because I had half a page to fill, basically. You could keep going with this. In fact, there is another band combination, a 571, that helps to view vegetation, but also water, and it has decent atmospheric penetration. And I have that one up. I was playing around with it just briefly. But that answers question number 4. You can see the number of screenshots that are required. Here they all are. And in question 5, what you're required to do there is show, you know, the before and after. So let me see if I can open this up a little bit more here. Right? And really, all we're doing there is, oh, sorry, not the before and after. Number 5 is showing the atmospheric penetration, or the ability to use a longer wave. The 765 band combination is great for seeing through relatively thin clouds, but also smoke and ash plumes. It's amazing. It's like turning them off, right? So that's what question 5 was all about. Question number 6 is just show the burn scar from the Kenora 51 fire after it was out. So again, what it's asking you to do there is go and look at the image that was captured or acquired from, I believe, October the 6th of 2021, once the fire was out, and you get a finalized, okay, there's no more burning happening here, and this is your final scar, right? So that's question number 6. It's just worth 1 mark. Number 7, pan sharpening, right? So the previous video, number 3, dealt with the pan sharpening process, but all we're asking for here is just show me a non-pan sharpened on the left and a pan sharpened on the right of the exact same area. So it proves that you completed that portion of the exercise. And there's a description at the bottom here that says at left 30 megapixels are showing non-pan sharpened, and so on and so forth. At right it's 15 megapixels that are showing pan sharpened imagery. That's it. So you're getting close to the end, and the very last question, or the very last portion of the activity, just talks about how amazing this imagery actually is. The spectral resolution, the many different band combinations and different resolutions that could be zoomed in and out of are just, it's amazing what you can do with even just a simple single Landsat 8 scene, right? That data set allows you to do so many cool things, and all you're asked to do here is just go back through the imagery, and I don't care whether you're going to be using pre-fire, during fire, after fire, just go and find a whole bunch of really interesting areas, things, and practice the enhancements, modify the gamma, play around with the contrast stretches to show that you have an understanding of how to make the imagery look and perform as good as you can, or as best possible scenario kind of thing for the way you make things look. And it's worth 5, meaning I need 5 screenshots. So I mean, I will quickly just go and grab a few. The band combination that I have up right now is a 571, and I think it's pretty cool. I am going to play around with it. I'm going to be using a different kind of capture. Well, no, I guess I can just do it on print screen, no problem. I'll just grab this and kind of put it right there. And go to 100,000. There's something kind of cool right here. That's all I'm doing now, print screen now. Do I want to go in beyond 1 to 100,000? Not necessarily. Obviously you could. So there's one. You can go back and modify these, and you can even further enhance them using Microsoft Word, believe it or not. Let's go back, and here's the thing. I also want to show each of you, and if you've watched this video to this point and you're still listening, here's a little extra for you. The thermal data, right? Channel number 11 and channel number 10, or band 11 and band 10, can be displayed using a different sort of method, right? So here's one of the thermal bands. It's band number 10. We also have band number 11. You can tell the difference between the two, and just by looking at the date, you can be like, oh, that's July 18th. Let's turn the July 18th image on. What are we at? We're at a 765, so that's pretty cool. So you can see that the fire's happening right here, and if you look at the thermal data, you'd be expecting it to be hot, right? It's a forest fire, right? So let's see what that looks like. In band number 11, you can see bright red. Well, how did I get this, right? If I select this channel and go to the symbology, look at what's going on. This is just a single channel. And the thermal data, I typically like to just use it as a single channel just because I'm able to see what's happening. Now, all of the really dark blue areas, what are those? Looks like they're clouds, right? The really orangey red areas are either areas that had burned or areas that are on fire during this active fire, right? So what did I do? When you first load just a single image in, right, you might get something that looks like this or whatever, but you've got to build the pyramids, and you've got to calculate the statistics in order to have it display properly. And that's no big deal to do in catalog, right? What I did was I looked for that July 18th image, right? Band 1, 2, 3, 4, 5, 6, there's band 10. You could just right click right in catalog and say build pyramids, right? And if you build the pyramids, what it's going to do is it's going to allow you to zoom in and out very quickly, and it'll also add it to the map. So it's a nice way of being able to do that. And once it's added to the map, you can start working with the symbology. and you can play around with different stretch methods. Obviously, this one's not going to make much sense, right? If we're talking temperature, what we should be looking for is a color scheme that makes sense, right? This would be the opposite. No, that's wrong. Can you invert that? You sure can, right? You can do that, or you can just work with one that goes from blue to red. Must be one. There's this one. Blue to red, except turn off the inversion and you're back to what you should be able to see. So things that would be really cold in this sort of image would be, well, clouds. Clouds can be colder than water because they're up in the sky, right? They're up in the air. Water, the water temperature in July versus clouds, there's a little bit of a difference. See that? See all the lakes, right? If you look at the image, all of the lakes that are on land are showing up as being relatively cool, but not as cold as the clouds. That's kind of a neat thing to learn. And of course the flames are the hottest, and so on. So if you want to use one of the thermal bands in your screenshot just to show how cool Landsat 8 imagery is in question number 8, by all means do that as well. I would love to see it. Right, this would be a good screenshot right here. Right, so that is pretty much it. That's going to take us to the end. I really do hope that each person, everybody, each student in the class takes your time with this to learn it, because it's really going to help with future labs that we have coming down the pipe, so to speak. We need to be able to work with Landsat data and understand that, you know, once you figure out and unlock its secrets, so to speak, you're off to the races, and you can. And the goal of this was to give you the ability and the knowledge and skills to be able to, at any point in time, go and use the Glovis application to grab a fire, or to go and look at glaciers, go and look at desert, go and look at different geology types. The Landsat 8 sensor is an Earth observation sensor, and it is absolutely amazing to view the data, and it's free. Like, you can just go and download it. Like, I'm a bit of a nerd by saying how cool this is, but it is pretty cool stuff. Okay, thank you very much. That's it.